Okay, 2.2 is subsets. This one only has 2 slides, which is good news. The bad news is it's definitions again. And the definition is one set is a subset of the other if every element in A is contained in B, which sounds a lot like they are equal sets, but we have to be careful with the language. And this is going to be very true in chapter 3, so just be prepped with being super careful with the language. But the language here is that every element in A is an element in the set B. That doesn't mean B can't have more things. And so with this definition, with the equal sign below, that means they could potentially be equal, but they don't have to be. So this is kind of like the idea of inequalities where we have less than or equal to versus less than. This is kind of the less than or equal to case, that every element in A is an element in B, and potentially they could be the same set. So let's see some examples. That seems like a terrible or a rough definition to actually track, but when we see definitions, it's not that bad of a definition. So in this case, the question's asking, we want to say two things are subsets of each other or they are not. And so that's similar to element or element not in the set. If we want to say something is not a subset, we put a slash through it. And so here we have A has 1, 3, 5, 7. B has 1, 3, 5, 7, 9, and 11. And so we notice that all of the elements of A are contained in B. Yes, B has more elements, so they're not equal, but they are subsets of each other. And so that's the idea of a subset. Can I fit every single element of one set into the other set? There might be other stuff left over, but I have to account for every single element. And so these two cases, A is a subset of B. Now, another example, A, X, such that X is a letter in the word proof. B, such that, or B is equal to Y, such that Y is a letter in the word roof. And so it is very important what the question is asking for. Are we asking if A is a subset of A, or A is a subset of B, or is B a subset of A? So the question here is A subset of B. And A is only a subset of B if every single element of A is in B. So R is in both sets, O is in both sets twice, F is in both sets, but A has an element here, P, that is not in B. So A is not a subset of B. Now, as an aside question, if we wanted to ask ourselves this, B is a subset of A, but that's not what the question is asking for. So moving on. Now, proper subset is very similar to this idea of a subset, except for we can't have the two sets equal to each other. So almost exact same definition here. It's just that we can use that symbol. We can say A is a subset of B if they are equal. That's okay. That can happen. If we're trying to figure out if something is a proper subset of another set, they can't be equal in order for that to be true. So to see this in practice, again, we're kind of getting caught up in the definitions. It's not that difficult of a definition if we run through examples. So here we are asked to write if A is a subset of B, or A could also be a proper subset, because both of those could hold, or maybe none of them hold. And so in this case, we have X such that X is a person that lives in San Francisco, and B is X such that X is the person and X lives in California. Sorry, it's and. So it's person and they live, person and they live. And so San Francisco exists in California. So every person who is living in San Francisco is also living in California. So not only is this a subset of each other, which makes sense based on the previous slide, it's the exact same thing. All of A is contained in B, but this is also a proper subset. So both of these are true. Right? Because they are not equal. So it's a subset, it's also a proper subset. Just like if we were thinking, kind of going back to the inequalities thought, if I was talking about 3 and 2, well, 2 is less than 3. Also, 2 is less than or equal to 3, so they can meet both of the criteria. Now for part B, A is 2, 4, 6, 8, B is 2, 8, 4, 6. And so that falls into the definition of two sets are equal. They're not ordered the same, but they have the same number of elements, and all of those elements are the same. So this one is a subset, certainly. That's good. That's true. But it is not a proper subset, because in order for something to be a proper subset, they can't be the same size. So those two are subsets of each other, but they are not proper subsets. And again, if something's not a proper subset, we just put a slash through it. So it's a very subtle difference between the two sets. If they are equal to each other, they are subsets of each other, but they cannot be proper subsets of each other, because if they are equal to each other, one or all the elements are contained in the other sets, and so that breaks, well, the second part of this definition. And that's, I believe, it for this section. Yep.